In the last lesson, we talked a little bit about the remainder theorem and how we can determine if a binomial is a factor of a polynomial that we're working with. And we started to look at how you could plug in, go back to it, we looked at how you can plug in to solve for the remainder when you divided a polynomial by some factor. And we could figure out what the remainder is. Now what we're going to look at is how, if that remainder is 0, it means that the binomial is a factor. So the factor theorem states that x minus a is a factor of a polynomial if and only if p of a, so when I plug in that a value into the polynomial, the result is 0. And if and only if means this works both ways. So if you plug in p of a and it equals 0, then that means x minus a is a factor. Or if I tell you that x minus a is a factor, then you know for sure that p of a would equal 0. So if we look at these first examples, these are asking you if these binomials are factors of this polynomial. So for x minus 1, we take 1, because that's the a value, and we plug it in. So 1 cubed plus 2 times 1 minus 13 times 1 plus 10. When I simplify all of that, I get 0. So this means that x minus 1 is a factor of this polynomial. When I look at x plus 2, the a value would be negative 2, because this is the same as x minus negative 2, that binomial. So the a value is negative 2. And when I plug that in, the result is 36. So that means x plus 2 is not a factor of this polynomial. Now, when we want to factor, the ultimate goal of this lesson, I should say, or of this unit, is to be able to factor these polynomials that are larger than quadratics. So we can use this idea of the factor theorem and the remainder theorem to help us. And what we know is that if x minus a is a factor of a polynomial, then a is going to be a factor of the constant term. So the constant term, remember, is that term on the end. In this one, it's 10. In this example down here, it's 6. But any factor of a polynomial, that a value is going to be a factor of that last digit. So if I asked you to fully factor this polynomial, I'm not giving you any of the factors to start with. So far, in all of our synthetic, or all of our division, I've always given you one of the factors to work with. But in this case, I'm not giving you any factor to start with. So how do you begin to factor? You're going to look at the factors of 6. So remember, the factors of 6 are 1, 2, 3, and 6. Factors are the numbers that multiply to equal this number. Now we can also have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, because we could also multiply our negative integers. We could multiply, for example, negative 1 and negative 6. So all 8 of these are our factors. And what you're going to do in order to determine one starting factor, because you know when we use synthetic division, I'm just going to cover this for a second. When we use synthetic division, we need to know what number it is to put here. So we know that we're going to divide this polynomial. Those are our coefficients, but we need to know what number we're dividing by. So in order to do that, you are going to plug in all of these factors into the polynomial. So you'll see here that I started with p of 1. P of 1, I plugged in 2 times 1 cubed minus 9 times 1 squared plus 7 plus 6. When you calculate all of that, the result is 6. So that means this is not a factor. I then did p of 2, plugged in 2 for all of these x values. The result then is 0. Now you might be asking, this could be a lot of work because there's 8 different numbers that you could plug in. So you want to try and make an educated guess when you're going to plug in. Try and look at these values and think, does that x value need to be really high? Do I need to plug in a number like 6 in order to get rid of a constant that might be really high? Try and use an educated guess. Once you know this a value that gives you a result of 0, you now have a factor, x minus a, in this case, x minus 2. So now that a value is what you put into your synthetic division. And you'll see that I've done that here. So I put 2 here. Remember to divide using synthetic division. We bring down the 2, then we multiply. 2 times 2 is 4. Then we add. -9 plus 4 is -5. Then we multiply again, bring it here, add to get -3, and then we multiply and add here to get our remainder of 0. Now I can write my partially factored form, which would be x minus 2, which comes from this a value, times the result here. So remember, 2x squared minus 5x minus 3. And then your very last step, this question asked you to fully factor. So you are going to then factor this trinomial right here using whatever method you wish. And your end result when this is fully factored is 2x plus 1, x times x minus 3, and then times x minus 2. So this is your fully factored polynomial. Try out some of these questions. The more you practice, the easier this factoring will get. And in the next lesson, we are going to learn how to graph.